Okay, class, here's a quick introduction to gaseq. I'll just load it up real quick. It's basically set up into several different regions. You have a problem type region where you can specify typical problem types. I usually just use these top four: temperature and pressure, or adiabatic, same temperature and volume, or adiabatic temperature and volume. Let's look at adiabatic temperature and composition at constant volume. We have a reactant section, a product section, and then a region here where all the properties are. The properties are given in the middle, and then reactants and products on the left and right. There are standard problems that are set up, so we can set everything ready to go for methane. We can also specify a number of different product types: extended, rich products, etc. We can look at the species. If we go to reactants, view species, add a new species to the reactant section. We can delete that species if we want. We can do the same thing over with the products. When we click on species, we enter the number of moles of that species. The mole fraction is given on the right. There's also, if you click on methane, for instance, the fuel, we can set the stoichiometry, set it to 2, and it will double the number of moles of the methane. Important thing to note is if you do that clicking on oxygen, go to 1.0, you can see it's going to change only the oxygen but not the nitrogen. So usually it's better to do that by setting the fuel itself. We can specify units if we want to use mass versus mole, if we want to use joules. All of those things are useful. Click calculate to run the code, and it'll specify the product temperature. That would be the equilibrium based adiabatic flame temperature, and then the equilibrium mass and corresponding mass fractions. One thing that's very useful to do is to compute the variations in something over a wide range. If we click on CH4 and then click, for instance, the stoichiometry phi, if we double click it, we can change the stoichiometry, the equivalence ratio, to go from, say, 0.5 to 2.5 using maybe 20 values, and we can send those to Excel by clicking the Excel link. The Excel file name can be left blank, and then we specify just what we want to output to the file. So in our case, we might want to take care of the stoichiometry, product temperature, a few of the product species, maybe all of them. Maybe we care about the density, and then we can hit OK. Opening the Excel link, we can click Go, and then we have some options here: calculate next, calculate everything else. It'll blow through. We can click View Excel. We go down and we get stoichiometry, product temperature, mass fractions. If you include in that list the mole mass fractions of the species, the mass fraction of methane here would be basically the mixture fraction. So it's a good thing to output for that. One nice feature is to be able to take products and push them over to reactants. That's a really useful feature if you're doing like a cycle where you want to take maybe a methane air flame, equilibrate it, then move the products over to reactants, and then set a new temperature or volume to get the corresponding energy levels as you're moving around different phases of an auto cycle, for instance. So there's many features that you can use. You can save everything to a text file, and it'll save basically what you see in a text format. You can also reload all of those things to recover from a saved position. Let me know if you have any additional questions, and go ahead and play around with the program to get familiar with it, but that ought to get you started.